The last video of semester 1. Assuming everything goes according to plan, anyway. Alright, this is the last video of the unit, and this is the last unit of the semester before finals and winter break, so savor it. Savor it. Maybe I'll make a review video for the semester, who knows. Alright, so it's kind of a shorter unit. We covered moles, molar mass, we reviewed STP, and we reviewed formulas. We kind of knew what formulas were already. And we tried to tie it all together with this conversion diagram thing. So I'm going to talk about each one of these, and I'm going to try and do some quick examples of just one-step conversions. The video I did previous to this, I did some harder ones, so if you want to re-watch that, if you're having trouble with the harder ones, you should do that after you watch this one. So let's actually start with the conversion diagram thingy. That's what I'm going to call it, apparently. Conversion diagram thingy. Very scientific, right? Okay, so we know moles goes in the center, right? Because everything can convert through moles. It doesn't really matter what direction you put everything else, but moles is connecting everything else. So let's just start with mass. So mass, we know it has units of grams, and we know to convert from mass to moles, we need the molar mass. Okay, so what is molar mass? Well, molar mass is how many grams in 1 mole. Right, so that's all molar mass is. It's how many grams in 1 mole. Oh, that didn't work. There we go. Okay, how many grams in 1 mole? So you calculate that from the periodic table, remember. And then you can use it for your conversion. Alright, what if I want to find an amount? Right, that's like atoms, etc., molecules, all that. Well, if I want to find an amount, I convert using Avogadro's number. Right, so Avogadro's number, which is 1 mole equals 6.02 times 10 to the 23rd. Technically, Avogadro's number is just the 10 to the 6.0 times 10 to the 23rd, but it's important that you understand 1 mole equals this, because without an equality, you can't do any conversions. And then we can also convert to volume, which we actually did at the beginning of the year without really knowing what a mole was. And I still haven't talked about it yet, so, oh, well, nothing's changed, I guess. And we know at STP, 1 mole equals 22.4 liters. Okay, so we talked about molar mass. Let's talk about Avogadro's number, where this comes from. So just remember from the reading that this was determined from experiments. This is how many atoms are in 12 grams of carbon-12, which is a specific type of carbon. And it's just a number used for counting things. Right? So you could have a mole of anything. You could have a mole of students, but that's a lot of students because this is a very big number, right? 10 to the 23rd, that's a lot of zeros. It's just a number to count things, like a dozen donuts. Why don't we just all say 12 donuts? I don't know. 12 donuts. See, there's 12 donuts. But instead, we just call this whole thing 1 dozen. Right, so that's the same thing we're doing for atoms, except it's, it would take me forever to actually draw 1 mole, 6.02 times 10 to the 23rd. 6.02 times 10 to the 23rd. It would take forever. That's why we use scientific notation. Okay, and this STP, just remember STP 273K or 0 degrees C. And then for pressure, it's 1 atm. 760 torr, etc. It's actually on the reference sheet, so you don't have to memorize it. You just have to know one of them, and then the conversions are there. Okay, so we talked about moles, talked about particles. I don't think we've talked about formulas at all. We've talked moles, molar mass, formulas, and we haven't done any examples. So let's look at a formula right now. So let's look at an example of a formula. Here's one you've seen before, magnesium nitride. Okay, so what this is telling me is that in one magnesium nitride, there are 3 magnesiums and there are 2 nitrogens. So I could use that in a conversion factor, right? Because if there's 3 moles of magnesium nitride, and I want to find out how many magnesiums there are, I know that there are 3 magnesiums for every 1 of the actual compound. And so I can set up my conversion factor like this and find that there are 9 moles of magnesium inside the actual compound. So there's an example of one problem with formulas. Let's do one for molar mass. So let's do the same thing, Mgn2. Let's say I start with, let's just pick a random number, 2.5 moles of Mg3N2, and I want to convert this to grams. So I want to go to grams of Mg3N2 from moles of Mg3N2. So I need the molar mass, right? Mg, there's 3 of them, has a molar mass of 24, plus nitrogen, there's 2 of them, mass of 14. You add that all up together, you get 100 grams per mole. So that's 100 grams for 1 mole. Mole cancels, 2.5 times 100 gives us 250 grams of Mg3N2. What else should we do? Ooh, moles and particles. So let's say you find out how much it weighs. Now you want to know how many particles are in that 2.5 moles of Mg3N2. So now you set up your conversion factor. You put moles on the bottom because you want to cancel out the moles. Mg3N2. And you want to find out how many particles there are. Well, this is ionic, so it's ionic particles. And we know that in 1 mole there are 6.02 times 10 to the 23rd ionic particles. That's Avogadro's number. And so you do a little multiplication there, you get not 1.5, well, I mean eventually. So 15 mental math 0.05, is that right? I think so. 2 times 4, 2 times 2 is 4, and then plus a half is 5. So 15.05 times 10 to the 23rd ionic particles, which if we want to do this in scientific notation, we have to move it over 1 so that it's always after the first number. And then we have to up the exponent 1, because whenever you move the decimal to the left, the exponent has to go up. Otherwise, you're just changing what the number is, as opposed to how you're expressing it. And then the last one is volume, right? We can't do volume with this because it's not a gas. So let's say we had 5.6 liters of fluorine gas, so F2. And we want to find out how many moles there are, or anything else, but we're going to have to go to moles first, right? Now let's, it has to be at STP, otherwise we have to use something called the ideal gas law, which you didn't learn. It's so sad. You should go learn it on your own. 5.6 liters of F2. So we know that at STP, right, liters of F2, and then we go into moles of F2. At STP, 1 mole is equal to 22.4 liters. So liters cancels. You divide this, do the long division if you have to. You should get 0.25 moles of F2, right, in 5.6 liters. All right, so we've done a bunch of examples, one-step conversions. If you're still having trouble on those multiple step ones, watch the video before this and sign up for super tutoring / get office hours. You know the drill. You're going to do great. I look forward to that celebration of knowledge. Celebrate good times. Come on. Okay. See you in class.